Hello, welcome to Prajim Technologies. I am Venkat. This is part 29. In this session, we'll be talking about the differences between classes and structures. In part 28 of this video series, we have understood that structures are very much similar to classes. We use struct keyword to create a structure, whereas to create a class, we use the class keyword. Just like classes, structures can have fields, properties, constructors, and methods. But however, there are several differences between classes and structures, which we will be exploring in this session. Now, a structure is a value type, whereas a class is a reference type. Okay, whatever differences are there between a value type and a reference type, all those differences are also applicable to a structure and a class. Okay, we haven't spoken about all the different types of value types and reference types that are available in .NET. So I thought we will be talking about the differences between, you know, value types and reference types at a later stage. But since we know that a structure is a value type, whereas a class is a reference type, I thought this is the right time to actually talk about the differences between value types and reference types. Okay, though we'll be talking about the specific value types and reference types in a later session. For example, there are several value types within .NET. Examples include the built-in data types like int, float, boolean, etc. Structures are value types, and enums, which we haven't spoken about, are also value types. Okay. Similarly, if we come to reference types, examples include classes. We have spoken about classes in the last session, and other examples include interfaces, delegates, etc. Again, we haven't spoken about interfaces and delegates, which we'll be talking about in a later session. So structures being value type, they are stored on the stack, whereas classes are stored on the heap. So what do we mean by the stack and heap? Now, when we run a program in .NET, you know, um, the variables and objects that you use within that program are actually created in the memory, and they are there in the memory until your program executes. So the physical memory of a computer is logically divided by .NET runtime into something called a stack and a heap. So if you look at the slide, let's say for example, if I have a simple program, here you can see a simple program. I have a simple customer class which has just got two properties, ID and name. Let's say I'm going to write a very simple program here. Int I is equal to 10. Let's say if I is equal to 10, let's say int j is equal to 20, and I want to create a customer object, new customer, and let's say c1.id is equal to 101, c1.name is equal to mark. Okay, this is a very simple C# program, just to demonstrate how these variables, the integer variable and customer object gets created in the memory. So now what happens is, we know that integer, structs are value types. Okay, actually if you look at this int, when I hover my mouse over that, you can see that this int is actually a structure, system.int32. Then what is this int? It is nothing but a keyword or an alias for system.int32 structure. It's just another name, and this is to give us the language specific syntax. Actually, instead of saying int, you can also say system.int32. This is perfectly fine. Okay, but we are used to other programming languages like C, C++, where we just say int. So int is just an alias for the structure system.int32. So you can either say system.int32 or just int. They mean one and the same. Okay, so since this I and j are actually integers and they are structures, so they are value types. So how they get stored in the memory is like this. Value types store the values on the stack where they are declared. But whereas on the other hand, we know that customer is actually a class, and we know that a class is a reference type. So for a reference type, you have two things. One is the reference variable. Here C1 is a reference variable. It's not an object by itself. and then the object itself, the customer object. So what happens when you say customer C1 is equal to new customer, and then C1.id is equal to 101, C1.name is equal to Mark? What's happening here is the C1 object reference variable gets created on the stack, and the actual object is created on the heap with those fields storing the respective values. So when we talk about an object, there are two things involved. One is the object reference variable, and the other one is the object itself. So objects are different from object reference variable. They are not the same. Object reference variables, in this case C1, is just a pointer to an object in the memory, on the heap rather. So object reference variables are stored on the stack, whereas the objects themselves are stored on the heap. Okay. So let's go back to the differences between classes and structures. So structures are stored on the stack, whereas classes are stored on the heap. Value types hold their value in memory where they are declared, but reference types hold a reference to an object in the memory. We've just seen that. Value types, I and j are value types. They hold the value where they are declared, but for reference type, the reference variables are stored on the stack, but the object itself is stored on the heap. Alright, value types are destroyed immediately after the scope is lost, whereas for reference types, only the reference variable is destroyed after the scope is lost. The object is later destroyed by garbage collector. We'll be talking about garbage collection in a later session, but let's understand this point. What happens to the variables and objects that we are creating? Now, if you look at this program, the scope of this I variable is the entire this main method. This variable has to be available until the runtime complete executing all these lines. Okay, but whereas this variable needs to be available only within this if block. Okay, which means this j variable will be destroyed as soon as the runtime finishes executing this line. Okay, let's say for example, if I have another code of line here, console.writeLine, maybe hello. Okay, so what happens is this j variable is destroyed. For example, when we run this program, what's going to happen is in the memory, I is created, which is initialized to 10, j is created, which is initialized to 20, customer object c1 is created, and the object is stored on the heap. Okay, so all these are created in memory when this code is running. Okay, so now I will live longer in the memory than j, because the scope of j is only within this if block. As soon as the control reaches this line here, then it removes this j from the memory, but whereas I will still be there. So value types are immediately destroyed as soon as the scope is lost. Okay, when the runtime comes, executes this line, even I is destroyed. But what happens to customer object? When we talk about reference types, there are two things: object reference variable and the object itself. For this customer C1 object reference variable, there is an object on the heap. So if you look at the scope of this reference variable, it is within this if block. So when the runtime finishes executing this line, the reference variable goes out of scope. So this reference variable goes out of scope. So what's going to happen is this reference variable get destroyed. Okay, this will be removed from the memory, but the object will still be there on the heap. Okay, so when will this object be destroyed? It will be destroyed when the garbage collector runs behind the scenes and it sees that it doesn't have any pointer to it, and it considers this as garbage and removes it from the heap. However, we'll be talking about garbage collection in detail in a later session. So remember that the value types, okay, are destroyed immediately after the scope is lost, whereas for the reference types, there are two things: object reference variable and the objects. For reference types, only the object reference variables are destroyed immediately after the scope is lost, but the objects remain in memory until they are garbage collected. Okay, so that's one very important difference between a value type and a reference type. So let's go back to the other differences. So value types are destroyed immediately after the scope is lost, whereas for reference types, only the reference variable is destroyed after the scope is lost, but the object is later destroyed by the garbage collector. When you copy a struct into another struct, a new copy of that struct gets created, and modifications on one struct will not affect the values contained by the other struct. This is another important difference between value types and reference types. What will happen when you copy a value type and what will happen when you copy a reference type? Let's look at that example. So if you look at this one, let's say for example, let's get rid of all this. Now let's say I have int I is equal to 10 and int j is equal to I. So at this point, what's going to happen is in the memory, okay, it's going to create two variables, I and j. Since I and j are structures because they are integers, okay, they're created on the stack. So I is initialized to 10, j is also initialized to 10, and we get two different variables. So we are copying this structure into this one. So what's going to happen for j, a new copy is created of type integer, and that value is copied over. So if you look at what happens in the memory, this is what will happen. It will create a variable I is equal to 10 and j is equal to 10. Okay, but now let's say I increment j is equal to j plus 1. So we are incrementing the value of j by 1. So what will happen to j? That will become 11. And then if I print the values, so console.writeLine, and we'll say, you know, I is equal to whatever is the value of I, and j is equal to whatever is the value of j. So I comma j. So now if I go ahead and run this program, what's going to happen? I value will be 10 and j value will be 11. So operations on j, modification to the value of j, will not affect the value contained by I. Because why? When you copy value types, okay, you get a copy of that object. So obviously operations on one variable here j, will not affect the value contained by. Why? Because they are two different copies. Okay, so obviously when I run this program, I value will still be 10, whereas j value will be 11. But on the other hand, let's go ahead and see what happens when we copy a reference type. We know a class is a reference type. So I'm going to create a customer object. Customer C1 is equal to new customer. And then we are going to initialize the customer object ID to 101 and customer name maybe to Mark. Okay, so now what I'm going to do, I'm going to create a customer2 object, and to this one I am going to copy C1. So what's going to happen, just like how we have copied I into j, we are copying C1 into C2. Here these are value types, j and I are value types, whereas C1 and C2 are reference types. Okay, so when I copy a reference type into another reference type, okay, so what's going to happen is, this is what is going to happen. It will not create a copy of the object, it will only create a copy of the reference variable. So we get two reference variables, C1 and C2, and both of them actually points to the same object. So obviously now if I make changes to these values either by this variable, by C1 or by C2, operations on this variable will affect the values contained by this. Similarly, operations on C2 will affect the values contained by C1. Let's see what we mean by that. Okay, now C1.id is 101, C1.name is equal, C1.name is Mark. So obviously both now C1 and C2 are pointing to the same object. So when you say either C1.id or C2.id, it will be 101. Similarly, C1.name or C2.name will be Mark. But on the other hand, let's say when I say C2.name is equal to Mary, now if I go ahead and print, so console.writeLine, maybe C1.name is equal to whatever in C1, and similarly C2.name is equal to whatever in C2. So C1.name comma C2.name. So now we are changing the value of the object we are changing this value from Mark to Mary using this reference variable. So what's going to happen? This Mark will be overwritten with Mary. Now, if I say c2.name, obviously it will be Mary. But what if I say c1.name? It will still be Mary. Why? Because these two reference variables are pointing to the same object. So if we go ahead and run this, c1 and c2 names, both of them will be Mary. But whereas in the case of I and J, they are different. Why? Because when you copy value types, you get copies. But when you copy reference types, you only get a copy of the reference variable, both of them pointing to the same object on the heap. That's why operations on one of the variables will affect the values contained by another reference variable. Okay, so that's another very important difference between a value type and a reference type, and obviously between a structure and a class as well, because a structure is a value type and a class is a reference type. Okay, so let's look at the other differences. Another difference: structures can't have destructors, but classes can have destructors. So structures can't have destructors, but a class can have destructors. Okay, we know that a class can have destructor. So this is a public customer class. So how do we have the destructor? Destructors will have the same name as that of your class, but with a tilde in front of them. So my class has a destructor. If I go ahead and build this, okay, destructors cannot have access modifiers. So if I go ahead and build this, my class will build successfully because classes can have destructors. But on the other hand, if this is a structure, structures can't have destructors. So if we go ahead and build this, we will get only an error stating only class types can contain destructors. So that's another important difference. Structures can't have destructors, but classes can have destructors. Another difference in terms of constructors: structures can have parameterized constructors, but they can't have explicit parameterless constructor, whereas a class can. Let's look at an example. Okay, so if this is a class, public class customer, I can say, okay, I need a constructor, public customer. This doesn't take any parameters. If we go ahead and build this, it will successfully build. Why? A class can have an explicit parameterless constructor. Okay, but whereas a structure can't have explicit parameterless constructor. So this is a constructor, but let's make this a structure just with the struct keyword. And we know that structure cannot have parameterless constructor. So if we go ahead and build that, we will get an error. Structures cannot contain explicit parameterless constructors. So that's another difference in terms of constructors and destructors for structures. Okay, and it actually makes sense because a structure doesn't have the concept of object reference variable and objects. That's why they don't need to have a parameterless constructor and a destructor, but whereas a class need to have them. Okay, structures can't inherit from another class, whereas a class can. Okay, structures doesn't support class inheritance, but both structures and classes can inherit from an interface. So structures don't support implementation inheritance, but they do support interface inheritance, but whereas classes support both implementation and interface inheritance. Okay, and examples of structures in the .NET framework we have already seen in 32, system.in32, system.double, which are actually structures, but the int keyword, double keyword, that we see in the C# programs, they are actually aliases, to the structures, just to give us, a flavor of the language, programming language kind of a syntax. All right. There are two things to keep in mind. A class or a struct cannot inherit from another struct, meaning a structure cannot act as a base structure for another structure or a class, because structures are sealed types. What do we mean by sealed types? For example, if we mark a class as sealed, let's say this is sealed class, public class customer, and I'm saying this is a sealed class. Now, if you mark a class as sealed, let's build this. So build solution, on the status bar you can see build succeeded. The only difference is we mark this class as sealed. Now when you mark a class as sealed, now you cannot use that class as a base class for any other for any other class. Now, what I'm trying to do, I'm trying to make this program class inherit from customer class. Now, what's going to happen if I go ahead and build this? It will give an error. Program cannot derive from sealed type customer. So this program class cannot derive from that. But on the other hand, if I remove that and go ahead and build the solution, it will successfully build. So remember, you use sealed keyword to prevent your classes from being inherited by another class. We use the sealed keyword. In fact, that's a common interview question that they will generally ask you. How do you prevent your class from being inherited by another class? Or what is the significance of a sealed keyword? Okay, and structures are inherently sealed types. So that's why they cannot act as a parent type for a class or for another structure. Okay, all right, so we have seen these differences. So here you can find some additional resources for ASP.NET and C# interview questions. That's it for today. Thank you for listening. Have a great day.